Welcome to In 5 Minutes. The agenda of this clip is to draw an equivalent Cmos inverter for simultaneous switching, assuming the W by L of PMOS transistor as 15 and W by L of NMOS transistor as 10 for the expression given below. Now before we start drawing an equivalent inverter circuit, we need to draw the schematic for the expression which is given here. With the shortcut technique which I have taught you in the previous clip, we know that any expression which is given to us, we need to hide the bar because the bar functionality is easily achieved by PMOS in the pull up and the NMOS in the pull down circuit. Whatever is underneath the bar is nothing but by NMOS or my pull down circuit, and exact opposite to it or exact complement to it is going to be my pull up. Let's understand this with an example of the expression. Here under the bar it's A plus E plus D. Plus means parallel, so pull down is A. Let's call this transistor input as A, plus E. E means another transistor input as E. And why have I connected in parallel? Because it's a plus sign between A and E. So is the case with D. So again D is also in parallel. So A plus E plus D. Then there is a dot. Dot means series. Series with what? B plus C. So B and C both are in parallel again. And B plus C, entire thing is in series with AED, that is nothing but AND. This is series connection, and this is my ground. This is my pull down circuit. Exact opposite to my pull down circuit is going to be my pull up circuit. What does that mean? It means that if A, E and D are connected in parallel in pull down, that is in NMOS, then in pull up A, E and D will be connected in series. Pull up is nothing but my PMOS, so let's quickly do that. A in series with E in series with D. Now this entire part for pull down was in series, so here this entire part would be in parallel to B plus C. In pull down B plus C was parallel, so here B and C will also be in series. B, C, and this is my pull up network, and I have connected with my pull down network, and this is nothing but my V out. This is my VDD, and this is my ground. So we have made the schematic. Now we have been given in the question that W by L for PMOS, all the PMOS's is 15, and for all the NMOS's is 10, and we have to draw an inverter equivalent. Remember, we studied series and parallel laws, in which we said that if W by L is same for all my series transistors, then my equivalent transistor replacing all the series transistors would have W by L divided by N, which is nothing but N being the number of transistors. So let's start with the first. These three transistors are connected in series and has same W by L. So it's nothing but replacing it with an equivalent PMOS whose W by L is nothing but W by L of the existing one. So that is nothing but 15. Divide by N. There are three transistors. So 3. So this chain or this branch equivalent is shown by 15 by 3. Now let's go to this. This is nothing but two transistors in series where both have W by L as 15. So this is nothing but W by L 15 divided by the number of transistors, which is 2. So this is equivalent to 15 by 2. Thus completes my pull up. Let's go to pull down. There are three transistors connected in parallel. When we know that the transistors are connected in parallel and has the same W by L, we know that W by L equivalent is going to be nothing but N times W by L. So there are three transistors, so N is 3, N into W by L of each, which is nothing but 10. So 10 into 3. Let's see the same thing for these two transistors. Again, W by L is same. So we'll draw its equivalent by 10 into the number of transistors, which is 2. And this is my ground and this is my VDD. So this is my equivalent circuit. We need to further simplify this. Let's redraw this and go to further simplification. So currently this is my circuit. This is nothing but 15 by 3, which is nothing but connected in parallel to 15 by 2. I have just drawn the equivalent. I have not changed the series and parallel connections, mind you. For NMOS, this was nothing but 3 times 10, and this was nothing but in series with 2 times 10, and this was my equivalent circuit. We took the help of this equation and this equation to simplify because W by L was same. Now if you see, my W by L is no longer same, and hence we will have to use this general formula for series and parallel connections. Let's start with the parallel connections first. So what is the equivalent of this PMOS? It says that you have to just add the W by L's for parallel circuit. So W by L parallel when W by L is not same is equal to W by L of, say this is transistor 1 and this is transistor 2 of 1 plus W by L of transistor 2, which is nothing but 15 by 3 plus 15 by 2, which very simply is nothing but pure mathematics from here on, by 6, so 12.5. So my PMOS equivalent is nothing but 12.5. Now let's quickly go ahead and see the corresponding NMOS equivalent here. Let's quickly do that. I have 2 transistors in series. NMOS is nothing but 3 times 10 into 2 times 10. So we will be following this formula for series transistors. So let's call this transistor 1 and this is transistor 2. So W by L equivalent is equal to 1 by, yes, that's correct, W by L of 1 by W by L of 1 plus 1 by W by L of 2, which is nothing but 1 by 1 upon 20 plus 1 upon 30, because this is W by L 20 and this is W by L 30, which is pure maths from here. That is nothing but 30 into 20 upon 50, which is nothing but 12. So my W by L for NMOS equivalent is nothing but 12. So we have got the PMOS equivalent, we have got the NMOS equivalent. We have to just substitute, or we have to just draw an inverter equivalent and substitute the value of W by L in that. Let's quickly do that. So my final circuit is nothing but PMOS, NMOS, input shorted because it's an inverter. This is my VDD, this is my ground, this is my input, this is my output, and you have seen that W by L equivalent for PMOS is nothing but, the size is nothing but 12.5, and W by L equivalent for NMOS, my size was 12. So with that we got a corresponding inverter equivalent circuit. Remember, for any such problems you have to just remember the general formulas for series and parallel, and if the W by L's are same, we have reduced the simplified formula as well. And remember not to change the series and parallel connections, but go through each branch, draw a corresponding equivalent, and finally what is left is nothing but your CMOS inverter. Hope you have understood this. Stay tuned for further clips, and thank you very much.